Life's online, so's mine. By fall we'll be okay. It's like your family is always near. When we haven't had our sports in over a month, it seems like a year. I'll be there for you to improve your last score. I'll be there for you like I've been there before. I'll be there for you 'cause you're there for me too.
Happy Monday, everybody. And we only have one more Monday left in this school year. And so I noticed that 9 of you are sending me and emailing me assignments and doing your work after 10 p.m. last night. So for you, Monday mornings must be rather rough. Or maybe it's rather easy to roll out of bed, but then picking yourself up off the floor is probably another thing. But at least look on the bright side. At least Mondays only happen once a week. You know that Sunday and Monday got in a fight. And you know who won? Sunday. Why? Because Monday is a weekday. And so, make sure you take attendance. This is Monday, May 11th, and this is e-learning. In store for this week, this is Math Counts week, and because if you're involved with that, Math Counts, since our state finals were canceled and there was no opportunity to for the national competition, Math Counts has provided a lot of activities because this would normally be the National Math Counts week. And so if you click on this link, you're going to see a lot of opportunities for this week. And so today, they all occur like they call it pie time at 3:14 p.m. And so that's after our e-learning day from 9 to 3. And so Monday, there's some math video challenges if you want to watch those. But Tuesday, they're going to create kind of a countdown round finals from a previous one, and so you might want to check that out. Wednesday, though, is the big day because we're going to do the open Math Count state competition. It'll be unofficial, but there will be prizes, and so that'll be exciting. You have to register, so click on that, register now, and look into that. If you need my help on anything, let me know. And so these are things you can do, and so that's Wednesday. Wednesday's the big day. Thursday, I think you can still finish up things till Thursday afternoon, and then they're going to go over answers. And so Wednesday and Thursday are great days, and then Friday they have some activity in the world's largest countdown round. And so really Monday and Tuesday, but I'll try to remind you of these things as the week goes on for Wednesday, Thursday, and Friday. Okay? And so for this week, we do have new warm-ups. A couple of you are falling behind, not very many of you, but there's 3 new ones. You need to click on those and the logic problems. And the logic problem hints for this week. The first couple. Find 3 numbers, just 3 numbers, that add up to 201. Which 3 of these? Boom, boom, boom. Those 3? Which 3 add up to 201? I sure hope I didn't click on the right 3. I better delete it quick. Oh, you could rewind and then figure out what the answer was. What 3 numbers add up to 222? Just pick 3 sections. Maybe it's this section, and this section, and this one. Well, I know it's not these 3 because this ends in a 0. So, and just highlight them, and you'll get it. Okay? So a couple quick ones there. Then over here, we have plug in the numbers 1 to 9. So you're using each of them once. And so 1, 2, 3, 4, 5, 6, 7, 8, 9. Just use each number once and only once. And we're ignoring order of operations. So for example, if we're going to add 2 numbers and then divide by 2, you're going to, hey, I'm trying to teach. And add 2 numbers and then divide by 2, you're going to add first. And so if you want these to add up to twice this. So if this is a 3, you want these to add up to 6. If this is a 4, you'd want them to add up to 8. If this is a 5, you'd want to add these up to 10. Okay? So there's lots of possibilities, and then you got to make these work down. How do you get to 15? And things like that. Okay? Then down here, you're counting total triangles. What I would do is count them one at a time. 1, 2, 3, 4, 5, 6. There's 6 that are just 1. And then write that somewhere. Now, how if I included 2 at a time? Or 2 sections? There's 1 there. There's 1 there. Here's 2 sections at a time. And then count them 2 at a time. Then you would count them 3 at a time. How many of those? Then you'd count them 4 at a time. And here's a 4 at a time. And then you got this big one. You got a big one. You know, you got quite a few. You count those. Same thing with rectangles. Squares are rectangles, so you count those too. And I would count the 1 at a times. How many 1s are there? And then count them 2 at a time. And then count how many of those. And count the 3 at a times and 4 at a times. And then come up with an organized way of counting those. Now this bottom part here, we did one like this the other week. I think it was 2 weeks ago. You're plugging the numbers 1 to 20 in exactly once, so you might want to write them out. A 1, a 2, a 3, a 4. And 2, it's just factor pairs. 2 numbers multiply together give you 20. But this problem's different because it has a diagonal. And on that diagonal, I didn't say how many pairs. It just says, so each row and column contain 2 numbers. Didn't say anything about the diagonal. Well, I don't want you to be confused since I'm not there with you. The diagonal only has 1 number, and it's a 20. And so where would this 20 go in order for this all to work? Well, look down here. Which one of these are multiples of 20? Well, there's 2 of them. And so it's either going to go in this column or it's going to go in this column. Ryan, the 240? Yes, you'd be correct. I'm telling you, this is where the 20 goes. And there's only 1 number, so all these are going to be empty. Okay? And that's my hint. And then the other hints you can use are from before. Okay? When we gave you hints on how to do this before. Okay? So think of the numbers like 19. Go 19 first, look for 19, look for 17, look for 13, look for 11, look for your primes that are higher. Okay? And if you can locate those, then everything else should fall into place. Okay? And then for the last one, move me out of here. For the last one, remove 3 matches so that each equation is correct. And so it doesn't matter. You don't have to write the letters of the matches. I was going to do that, but... And good luck trying to get the other 2. And so if we look at this last one, 8 times 9 plus 76, does it equal 90 plus 36? No, it doesn't. Well, I got to remove 3 matches. Well, if I remove this one, this would make a 0. 0 times 9 is 0. And 0 plus 76, 76 trombones that lead the big parade. Could I make the other side equal to 76? Yeah. You would just scribble out this one, and you would scribble out this one. And that would be 40 plus 36. And see, you showed me what 3 matches you scribbled out. And you can even show me that you get 76 on both sides. And so there, that one's done. Now you got 2 more. Okay? And you just have to eliminate 3. There's no tricks. It's just eliminate them so you can figure out the answer. Okay? And so logic problems, many of you have been doing them. I hope you've been enjoying them. And that's a way to raise your grade. And so if your homework, you're getting 10s, 9s, you get an 8 or a 7. It's like, oh, my grade's not good. Just turn in some logic problems. Boom, you're good to go. And so make sure you get those in, and we only have a couple more weeks of these, okay? So let's go to the notes and see what's in store. So for pre-algebra today, let's scroll down and see. We're going to continue graphing inequalities, but we're going to graph systems of inequalities. And so we're going to put 2 inequalities together and figure out where the common solution is today. And so for the notes, get these printed off. We're going to review what systems of equations are, and so that is where the 2 lines cross, and we name the answer as an ordered pair. And so for these first ones, we have, Thomas, what's the m and the b for y equals x minus 3? Yes, the m is 1 and the b is negative 3, and so we're going to graph that. We start at negative 3, and then we rise 1, run 1. and we run to the right, and then we're going to graph that. And so hopefully, maybe I should have made that red. And then the next one, what's the M and what's the B? Ryan? Yes, -2 and +3. And so we have +3, and then we're going to drop 2, run 1, drop 2, run 1, bing, 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 bing. I think I know where the lines cross. And so if we take a look at this, everything shifts a little bit, so I don't like that on the computer. But where is this line where they cross? Where is the point right here where they cross? Josiah? 1, 2? No, that'd be up here. Oh, you mean -1, 2. Well, that'd be over here. Oh, you mean 2, -1. Yes. Right 2 down 1. There's infinitely many points on the one line. There's infinitely many points on the other line. But where is the common point? Well, the common point is where they cross. Oh, by the way, this is notes. 1 doubleds 2, 2 doubleds 4. It's notes 124. Okay? Let's graph the next one. What is the M and what is the B? So, Caden, what's the M and the B for y equals the opposite of x plus 2? Yes, -1 and 2. Where are we going to begin, Caden? Yes, at the 2 on the y-axis. Then how do we do a slope of -1, Scott? Down 1 over 1. Which way's over, Red Rover? To the right, to the right. And so down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. And so we're going to get the graph of that. We'll get it matching colors. And there's infinitely many points on this line. How many points do I need to graph? Infinitely many. And so how many points? Infinitely many. And that's why we connect them and put arrows. And the next one, y equals 2x plus 5. Baylor, what's the M and the B? 2 and 5. Where do we begin, Baylor? At the 5. And then if we have a slope of 2, we rise 2, run 1. Rise 2, run 1. Oh, look. We could also go backwards, down 2, left 1. Because a negative over a negative, see, this is 2 over 1. Well, that's also -2 over -1. And that's how you can go down and left. You both need to be a negative. And so we'll get our trusty rusty line maker right here. And we're going to graph that. And where do those two lines cross? Xavier? -1, 3. Yes, because we're going left. And then we climb up the swimming ladder. That's what Anna always used to say. And so left 1, up 3. And so this has infinitely many solutions. This has infinitely many solutions. But there's only one solution that is in both, and it's that one. Well, then on Friday, we started changing the equal signs to greater than and less than signs. And so when we got to these, we said, what is the M and the B? Where are all the ordered pairs that make the y value greater than -3 times the x value plus 1? And you don't just want to pick them and plug them in and see where they are and then see that the birds of a feather flock together and then figure out all that. We have an efficient way where we just graph the line where m is -3 and b is 1. And so if we're here at 1 and we're dropping 3, running 1, and dropping 3 and running 1, and dropping 3 and running 1, and we graph this, but before I get excited, is this going to be, Phoenix, a solid or a dashed line? Yeah, it's going to be dashed because this would have been an open dot. And so don't get all excited. And I got to be able to tell if it's solid or dashed, not scribble and I scan it and take a dark picture. And I need to be able to tell if it's solid or dashed. Make it easy on me. And then, what side of the line do I color? Read this to me, Connor. Y is, I didn't hear you. I got to hear you say it. Connor, Y is, a little louder. Yes, greater. So is that the sky or the ground? Look at this. If this looks like a picture, and I said color the sky, it wouldn't be this side. It's this side. Now, it's not always the right side, because it just matters which way the line is angled. But here the sky is over here. And so we have that. Now, this next one, what's the m and the b for this? Owen? Yes, this would be plus 0x. Owen, m is 0, and then b is 3. And so if we start at 3, what type of lines have 0 slope? Straight lines? They're all straight until later in the week. And then they're not lines, they're non-linear. But they're all straight. Oh, I meant, horizontal. Yes, yes, yes. Owen, would this be solid or dashed? Oh, yes, dashing through the graph. Stop it, Mr. Nyson. It was even... I know. And so are we going above or below? How do we know? We read right there. Joseph, read that to me. Y is... A little louder. Joseph? Y is less than. Yes. So are we above or below this line? We're below. Maybe we want to go green and recycle. Color the grass green. Twice as much homework. How does that work? We're going to put this graph on top of the wasn't that cool? You wish you could do that. We're going to put that graph on top of that one. And where's the common answer going to be? Where they overlap. So you can color them both. Because in this problem, the yeses live on this side, the no's live on this side. The yeses live on this side, the no's live on this side. So where are the yeses to both? Well, they have to be in the common region, the region that's overlapped, and there are infinitely many points. And so we cannot name them all. And so what do? We graph them. If we could name them, we'd name them. But you know what they say? A picture is worth 1,000 words. And so a picture is worth an infinite amount of points is what we got. So here's what your assignment's going to be like. So we have example 1 and example 2. So what is the m and the b for y is less than x minus 3? And so the m is 1 and the b is negative 3. So we're going to start at negative 3. And then we're going to rise 1, run 1, rise 1, run 1, rise 1, run 1. And the line is going to be solid or dashed. What is it, Tucker? Yeah, it's going to be dashed. I got to make sure I get this looking good here. Okay? And now you can decide if you want to color it lightly or darkly or color code. You know, yellow and blue make green. And you can try to do the color wheel on this. So we're going to go above or below that line right there. Lucas, y is less than. Good job, Lucas. And so we're going to be below this line. And then here, what about the next one? Lincoln, what's the m and the b for this one? Negative 2 and positive 3. And so we're starting at positive 3 on the y-axis. And then we're going to drop 2, run 1. Which way is running? To the right, to the right. And so we have that, and that crosses there. Now we're not just interested where the lines cross. These are inequalities. We are interested in where the regions cross. And so this one, is it going to be solid or dashed? Alex? Yes, it's going to be solid. And that's not a blue line. I wanted a blue line. And so click on blue. And so we got our solid blue line. And then yellow and blue make green. We'll see if this works. Blakely, read that to me. Y is greater than or equal to. Well, the equal to makes the solid line. But the greater than is here. Does yellow and blue make green? No. The computer doesn't know their color wheel. But where is the common region? Well, it's right here. So you can color both of these light, or you can just try to color this one dark. Okay? Or maybe we should overlap it in green. And so try to color it dark. That is the yes to both. Now, some of you are asking, on Friday, is the line the yes or the no? Because there was one point you plugged in, it was on the line. Well, if you're on the dashed line, it's a no. If you're on the solid line bordering this region, this part of it right here is a yes. That border is a yes. This border right here, because it's dashed, would be a no. But the section itself would be, Yes. Okay. So let's look at and let's do the last problem on the notes. This one, it might not look like that we have many numbers, but we still have an m and a b for each one. And so, Tennille, what's the m and the b for this? Y is less than or equal to x? Yes, there's a 1. That's the what property? Yes, the identity property. And also, we have the identity property here, 1x plus 0, the additive identity and the multiplicative identity. And so we have an m of 1 and a b of 0. So we're going to begin at 0, and then we're going to rise 1, run 1, rise 1, run 1. And this is going to be a solid or a dashed line, Tennille? Yes, solid line. And are we going above or below it, Ainsley? Yeah, read it to me. Y is less than, so we're going below. And so maybe we'll color that green because it's the grass. And we're going, there's all the yeses, including the line for that one. Then for the second one, we have y is less than 5. So what's your m and the b for this one? Brady? Yes, m is 0. Why is that? Yeah, because there's 0 x's. So your m is 0 and your b is 5. So we're going to begin at the 5. And then a 0 slope is, Jack? Yeah, horizontal. And is this, Jack, going to be solid or dashed? Y is, read it to me, Jack. Y is less than. And so there's no, it'd be an open dot. And so that's going to be a dashed line. And so we got dashed line. Make sure I can get everything here. And so dashed line, that's a little high. Move it down there. And we're going above or below, Jack? Yes, we're going below. So when you go below both of them, you'd be below here, but you want the overlap. And so if you can't tell, like in this, what got hit twice, really the only solution is what gets hit twice. And so you want to color the overlap. And so if you want terrible colors, pick the ones I picked. You're like, Mr. Nice, and that clashes. And so, sorry, Katie. And right there. So that's your yes to both because you're below both lines. And so that's your yes, yes. So you got 8 questions. You really got 16 because you got to do 2 on each one. But you really only have 8. It's just the front side. And let's take a look at those. And so I'll let you pick one we're going to do. Okay? So which one would you like to do together? If we were in class, we'd give you stickers. So this is assignment 124. And which one do you want to do together? Number 7? Okay, let's do number 7. Y is greater than 2x minus 3. So we got an m of 2 and a b of negative 3. Make sure you don't get the wrong b. If you're in class when you're doing 2 of these and you mess up, you'll be like, I need a new worksheet, Mr. Nyson. But guess what? I'm not there, so you have to just print another one. And so if you mess up. And so we're going to rise 2, run 1, rise 2, run 1, rise 2, run 1, rise 2, run 1. And this line is going to be dashed. Well, it's rather dashing. Dashing through the graph. Hopefully the snow is over. And see, we're going to go above that one. And so above that one would be right here. And that would be all the solution sets to that. Well, then let's graph the other one. What's the m and the b to the other one? What would it be? Layla? Yes, the m is 2 and the b is 6. And so we start at 6, and then we're going to rise 2, run 1. What do you notice about these two lines? Yes, they are parallel because they have the same slope. So when you graph these, hopefully they look parallel. And they're both dashing lines. Ooh, they look good. They're rather dashing. And so we have a dashed line here. But are we going, whoa, that doesn't look very parallel. You want to make them look parallel. And so there's the other one. And on this one, we're going below. And so we're going below this line. So this blue one, we're going below. We're going above the other one and below the other one. Well, what is the set of points that's a yes to both? What would that be, Ethan? Yes, it'd just be the points in between. Well, this is simply how my Atari video game system, when I was a child, and we'd play a driving game, and there would be this road, and the road was just straight lines, and we got excited if they just turned a little bit. Whoa, that was cool. But notice we can draw a road on a computer. We can just say graph the set of points that are above this line and below this line, and all of a sudden we got a road. And we can go somewhere. And that's what you would do. And that is the solution set, and that was the beginning of simple computer graphics. And nowadays they got games in progress and design for years, and you can see all kinds of cool graphics. Okay, and so there's one example. We got one of them done, and the first one, just so nobody misses it, what's the m and the b? Peyton, for y is greater than negative 1/3 x plus 2. Yes, it'd be 2 would be your b, and negative 1/3 would be down 1, run 3. And so you got that line. That line's going to be dashed, and you're going to go above. And then this next one, what's the m and the b of this one? What would it be? Max? Yes, 1x plus 0, using all those identity properties like we did on the notes. And so we have a 1 and a 0. We're going to begin at 0, and we're going to rise 1, run 1. Great job, Max. And that line's going to be dashed, and we're going to go below. So if we're going below this one, and we're going above this one, the section we're going to want is right there. And so you work on the rest of them. Email me. Let me know any of your questions, and I hope all of you have a great day. We miss all of you. Just keep up with the good work. Knowing all this next year is going to make Algebra 1 much easier, and so make sure you're getting everything done, okay? And so have a great Monday, everybody. We miss you. Bye-bye.